All right, let's talk about television. Not the sleek screens we have today, but how we got here. We're going to dive into the incredible story of how we went from these fuzzy, almost ghost-like images made by spinning pieces of metal to the vibrant, full-color window to the world that we all know today. It's a wild ride.
I mean, it sounds completely nuts, right? Before there were electron beams or digital pixels, the very first TVs were basically these mechanical gadgets that literally use spinning discs to create a picture. So the big question is, how on earth did a spinning piece of metal become a window into another place? So our story really kicks off with this guy, the Scottish inventor John Logie Baird. Back in 1925, he showed the world the first ever working television. And yeah, it was this clunky contraption of gears and spinning parts, but it was the breakthrough that started everything. The genius of this thing was really in its simplicity. Just picture it. You have a disc with a spiral of holes, and it's spinning like crazy. It scans an image, one little line at a time, and turns the light it sees into an electrical signal. Then, on the other end, another disc, perfectly synchronized, uses that signal to power a light bulb, essentially repainting the image dot by dot, line by line. It moved so fast that your eye would just blur it all together into one single moving picture. Pretty clever, right? But for all its cleverness, the system had some really clear hard limits. The picture was made of only 30 lines, which, as you can imagine, was incredibly blurry. And at just 5 frames per second, the motion was super choppy. But here's the real kicker. To get a better picture, you'd need a much bigger disc spinning at terrifying, dangerous speeds. Mechanical TV had literally hit a physical wall. And this really shows you the massive leap that was needed. To get a sharper, smoother image, you had to find a way to paint pictures much, much faster than any physical object could possibly spin. The future of TV meant getting rid of moving parts altogether and jumping headfirst into the world of electronics. And the solution was this: the cathode ray tube, or CRT. Just think of it like an electron gun. It literally shoots a beam of electrons at a screen, and a set of powerful magnets steer that beam with unbelievable precision, painting an image line by line, way faster and way clearer than any spinning disc ever could. No moving parts, just pure physics. So, okay, the engineers had totally solved the screen. That's a huge step. But that was really only half the battle. They still needed an electronic way to capture the image in the first place. I mean, how do you even invent a camera that doesn't need a spinning disc? Well, the answer was a completely revolutionary new kind of camera. Inside, it had this special plate covered in thousands of tiny, light-sensitive dots. It's kind of like an electronic canvas. When light from a scene hit the plate, it created an electrical painting. Then an electron gun would scan this painting, row by row, and turn it into a video signal. This was it. This was the final piece of the puzzle for a fully electronic TV system. So, black and white television was finally a reality, and it was becoming a huge sensation. But of course, engineers were already chasing the next, much, much bigger challenge, bringing the world to the screen not just in shades of gray, but in full, living color. Now, their first idea was kind of a brute force approach. A camera would use prisms to split light into red, green, and blue, and record each color on a separate tube. Then, the TV would have 3 separate electron guns to display them, and they all had to be aligned perfectly. As you can imagine, this whole setup was incredibly expensive and just a total technical nightmare. But you know what? The crazy cost wasn't even the biggest problem. The real issue, the one that almost stopped color TV from ever happening, was this massive compatibility crisis. See, by the early 1950s, more than 5 million American homes already had a black and white TV set. You couldn't just launch a new color system that would turn all of those expensive new sets into useless boxes overnight. Whatever they invented had to be backward compatible. The old TVs had to be able to understand the new signal. So the first big breakthrough actually came from inside the TV set itself. Instead of that clunky system with 3 separate tubes that had to be perfectly aligned, engineers figured out a way to create a single screen that could display all 3 primary colors at once, using just one cathode ray tube. The secret was this brilliant little invention called the shadow mask. It's a super thin sheet of metal with thousands of microscopic holes, and it sits right behind the screen. It basically acts as a perfect guide, making sure the electron beam for red only hits the red color dots, the green beam only hits green, and so on. It was such an elegant solution to a massive precision problem. Okay, so the TV set was solved, but that just led to an even tougher puzzle. Broadcasters had a very specific, limited amount of airway space, what we call bandwidth, for a single black and white signal. So how in the world could you possibly squeeze three different signals for color into a space that was only designed for one? And this is where the real genius comes in. The engineers came up with this incredible trick. First, they combined all the red, green, and blue information into one standard black and white brightness signal that any TV could understand. Then they created two much smaller signals that only carried the color information. And here's the magic part. They figured out how to hide those small color signals inside the main brightness signal, almost like writing a secret message in invisible ink. And that was it. That was the perfect solution to the compatibility crisis. An old black and white TV would get the broadcast, see the main brightness signal it recognized, and just completely ignore the hidden color data. But a new color TV, it knew the secret. It could find that hidden data, decode it, and combine it with the brightness signal to create a beautiful, full-color picture. It was a win-win. And with that problem finally solved, this historic moment arrived in 1953. With just the press of a single button, the United States officially adopted this new compatible system, becoming the very first country in the world to broadcast in color. But even with the technology approved, the switch to color wasn't like flipping a switch. It was a long, slow process. In fact, it took almost 2 more decades, all the way until the early 1970s, before the number of color TVs in American homes finally outnumbered the black and white ones. And yet, that incredibly clever method of hiding color inside a black and white signal was so successful that it became the broadcast standard for over 60 years. It only gave way to digital TV in the 2000s. It's the technology that allowed television to truly go global. So when you really trace that whole journey, all the way from a clunky spinning disc in a lab to a clever signal hidden in the airwaves, you realize the story of television isn't just about cool gadgets. It's a total masterclass in creative, elegant problem solving. This innovation fundamentally changed how we all see the world. And it really makes you wonder, doesn't it? What's the next hidden signal being developed right now that's going to completely transform the technology we all rely on every single day?